This is shuttle launch control at T-minus 8 minutes, 56 seconds and counting. The launch events are now being controlled by the ground launch sequencer from now up to the T-minus 25 second mark when they switch to the onboard redundant set launch sequencer. The ground launch sequencer is part of the launch processing system and operates by relaying commands to the orbiter's onboard computers, which then report back to the launch processing system that the commands have been executed successfully. The countdown at T-minus 8 minutes, 20 seconds and counting. The primary job of the onboard computers is to check that all of the launch commit criteria, such as propellant loads, temperatures, pressures, and other measurements, are normal. Just past the 8-minute point in the countdown, everything proceeding smoothly towards a liftoff. The liftoff, planned liftoff time, 11:15 and 30 seconds. Coming up on the T-minus 7-minute 30-second point in the countdown, the crew access arm now retracting. This is the walkway used by the astronauts to get from the service structure to the orbiter. If an emergency should arise, that arm can be put back into position within 15 seconds. The Johnson Space Center now sending a final update to the onboard computer for antenna management. The AC electrical bus sensors have also been placed in monitor by the pilot Ron Graby. T-minus 7 minutes and counting. At the 6-minute point in the countdown, the pilot Ron Graby will perform the auxiliary power unit pre-start. Everything going smoothly as we proceed towards a liftoff at 11:15 and 30 seconds this morning. T-minus 6 minutes, 30 seconds and counting. The pilot, Ron Graby, has been asked to perform the auxiliary unit pre-start. This consists of positioning a number of switches and verifying that they're in the proper position. Then throwing the 3 propellant isolation valve switches, which allow the hydrazine fuel to start flowing from the tanks towards the APUs. T-minus 6 minutes and counting. Pilot Graby reporting the APUs are configured for startup. We've had a final go from the weather people for the launch this morning, both for the pad area, the shuttle landing area if there should have to be a return, and the various contingency areas around the world. T-minus 5 minutes, 30 seconds and counting. The flight recorders are on. The flight recorders provide measurements of the shuttle system performance during the entire mission for playback after landing. 15 seconds away from the T-minus 5-minute point when we get a go for APUO's start. T-minus 5 minutes and counting, and we have a go for APU start. The APUs provide auxiliary power, hydraulic power, to move the aerosurfaces and main engines for steering. The liquid oxygen fill and drain valve in the external tank has been closed and topping of that tank completed. And liquid oxygen drain back has been started. This means that liquid oxygen is flowing through the main propulsion system and back to the large storage tank to cool the system down slowly to minus 270 degrees below zero. And we've had a report back that APU start has been completed. T-minus 4 minutes, 13 seconds and counting. The firing circuit for the solid rocket boosters ignition and range safety destruct systems have been armed. T-minus 4 minutes and counting. The astronaut crew has closed the visors on their launch and entry helmets, and the final helium purge of the orbiter's main engines has started to ensure that there's no surplus hydrogen or oxygen in the area at the time of ignition. The ground launch sequencer has determined that the APU hydraulic pressure is now normal for launch and flight. T-minus 3 minutes, 30 seconds and counting. The shuttle now on internal power. And the Elevon speed brake and rudder have been moved through a pattern to ensure they're capable of doing their jobs during the mission. The engine gimbal or movement check of the main engines in the orbiter now underway. T-minus 3 minutes and counting. The liquid oxygen valve for filling the external tank is closed and pressurization has begun. After the tank is pressurized, the hold capability is limited to 3 minutes and 36 seconds. T-minus 2 minutes, 40 seconds, and the caution and warning has been cleared, and the gaseous oxygen vent arm presently being retracted. T-minus 2 minutes, 30 seconds, and counting. T-minus 2 minutes, 15 seconds and counting. The main engines have now been moved to the start position, and the astronauts have cleared the caution and warning memories, and all systems are verified normal for launch. T-minus 2 minutes. The liquid hydrogen vent valve has been closed and flight pressurization is underway. T-minus 1 minute, 45 seconds and counting. The computers will automatically verify the readiness of the main engines at the 1 minute point. T-minus 90 seconds and counting. T-minus 1 minute, 15 seconds and counting. The liquid hydrogen tank now at flight pressure. Coming up on the 1 minute point, T-minus 1 minute and counting. The firing system for the sound suppression water system now armed. And the hydrogen igniters under the orbiter's engines have been armed. These devices ensure that any hydrogen is ignited prior to building up. T-minus 45 seconds. Just seconds away from switching command of the countdown to the onboard computers. T-minus 35 seconds. T-minus 31 seconds, and we're switching control. We have go for auto sequence start. And we have the sequencer on the orbiter now controlling the final seconds to launch. 20 seconds and counting. The body flap and speed brake in launch position. T-minus 12, 11, 10. Have go for main engine start. T-minus 6. We have main engine start. 4, 3, 2, 1. Ignition and liftoff. Liftoff of Atlantis. A new orbiter joins the shuttle fleet, and it has cleared the tower.
Roll program initiated. Crew confirms roll maneuver. Pass through the area of maximum aerodynamic pressure on the vehicle. Booster confirms engines throttling down. Velocity now 2,000 feet per second. Altitude 2.7 nautical miles. Downrange distance 1 nautical mile. 3 engines performing normally. 7,400 feet per second. Engine throttling up now back to 104%. 1 minute, 10 seconds. Crew giving a go at throttle up. Commander Bo Bobco acknowledging that go at throttle up. Velocity 3,500 feet per second, altitude 12 nautical miles, downrange distance 9 nautical miles. Three engines running 104%. APUs and fuel cells have normal indications. Velocity 4,600 feet per second, altitude 18 nautical miles, downrange distance 16 nautical miles. Coming up on approximately the 2-minute point at which SRB separation will occur. Standing by for separation. Crew confirms PC less than 50. And we have solid rocket separation. Guidance converging as programmed. Velocity 5,500 feet per second, altitude 28 nautical miles. Downrange distance 34. Three engines still running 104%. Velocity 5,800 feet per second. First stage performance nominal. Crew advised of nominal first stage performance. 2-engine transatlantic abort capability. Atlantis now capable of reaching a transatlantic abort on 2 engines if that should become necessary. Velocity 6,200 feet per second, altitude 38 nautical miles, downrange distance 58 nautical miles. 3 engines 104%. All systems looking good at this time. At approximately the 4-minute point that we will reach the negative return call. At that point, the Atlantis no longer capable of doing a return to launch site abort. Return status and mission control underway. Velocity 7,400 feet per second, altitude 48 nautical miles, downrange distance 95. 3 engines running 104%. All systems continue to look good. Standing by for negative return. Crew advised negative return. Atlantis no longer capable of returning to launch site in the event of an abort. All systems in mission control give a go. 4 minutes, 15 seconds. Velocity 8,800 feet per second. Altitude 54 nautical miles. Downrange distance 143 nautical miles. 3 engines still performing normally. 3 good APUs and 3 good fuel cells. Crew given a go to press to main engine cutoff. That is a capability of reaching a normal main engine cutoff should there be a single engine failure. 5 minutes, velocity 10,600 feet per second, altitude 57 nautical miles, downrange distance 209 nautical miles. All systems on board the Atlantis continue to look good at this time. Minutes 35 seconds, velocity 12,300 feet per second, altitude 58 nautical miles, downrange distance 269 nautical miles. Standing by for the call for single engine transatlantic capability. Atlantis Forward velocity now enables it to reach a transatlantic abort if that would become necessary in the case of 2 engines out. All engines continuing to perform normally at this time. All systems on board Atlantis look good. Velocity 14,300 feet per second. Altitude 58 nautical miles. Downrange distance 340 nautical miles. Standing by for a single engine Preston Eco call. At that point, the Atlantis capable of reaching normal main engine cutoff on only 1 engine. Guidance officer reports navigation is good. Velocity 16,300 feet per second. Altitude 57 nautical miles. Given the call up for single engine press to main engine cutoff, capable of reaching main engine cutoff on single engine if that's necessary. Crew read up a change in the earlier call. After analysis of the data, the first stage performance indicated low. That just affects the later trajectory.